Okay, in the lecture 1, we talked about your possible career options, and then we talked about the importance of documentation, right? And then the third most important topic we'll discuss today is the scientific measurement, okay? So I have a slide here where a simple mistake of conversion between two measurement systems costed about $125 million. That mistake was made by the NASA scientist. Okay, so if you're working in a biotech industry, okay, you are making a very expensive injectable drugs. So a simple mistake again can cost millions of dollars for your employers, and he or she would not be happy. Mostly it's going to be your supervisor, and then your job could be jeopardized. So you don't want to make any mistakes. That's costly, right? So scientific measurement, it's from your textbook chapters 17 through 22. So how do you define a measurement? Measurement is a quantitative observation or numerical description. Okay, so you can measure the weight of your compound, or temperature, so thermal energy of your whatever the molecule you're dealing with, or volume if you're dealing with a liquid substance, or time. Those are all important measurements of different kind. So how you measure it? You measure it by doing an assay or test. So measurement of a property of a sample is called a test or assay. Okay, so testing or assaying is a very important part of biotechnology job. Okay, you will be measuring out a whole bunch of things in daily basis. So then, how do you perform a good measurement? So how do you define that? A good measurement is a measurement that is done, and then it will be trusted by your team or your company. So basically, there should not be much error in your measurement, in your performance, right? So important fundamental concepts and definitions in measurement. Number one, when you measure something, you have to use a kind of unit. Okay, if you're measuring the length of certain thing, you may be using a metric system in centimeter or meter unit. Or if you're measuring a temperature, you may be measuring in scientific unit, degree in Celsius. If it's a volumetric measurement, you may be using a liter or milliliter. So those are all important units that you will be using in your measurements. Okay, and mostly the units you'll be using will be international units that other people will be using. So unfortunately, the US measuring units are not international, so it's based on the imperial units, but the rest of the world is not using the units. So when you work in the biotech industry, you have to use the international unit. Mostly that is the matrix unit. So you have to be familiarized with the matrix unit if you're not already. Okay, so System International Measurement System is what you're going to be using. Okay, so established to provide the common units of measurements to everyone in the world. So take a look at your textbook, page 222, 226, and 227. It will tell you what those are. And when you measure something, okay, how do you know your measuring device is doing its job? You can check that by comparing your measuring device against something called a standard. Okay, standard is a physical object that embodies a unit. Okay, if you are measuring a weight of something, so you will be using an instrument called balance, right? So to check the capability or condition of the balance, you can use a standard, weight standard, and place that weight standard on top of your weighing dish of your balance and see how your balance measures the standard. If that standard comes with a certain weight, let's say it's a 500 gram standards, if your instrument, your balance is doing its job, it should read very close to 500 gram weight. If not, then there's a problem on your instrument, the balance at the time, right? So standards are used for that function. So it will measure your instrument against the defined unit. If there's a gap between what's defined unit on the standard and what your instrument is measuring, there's a problem. You have to go through a calibration process to fix that, right? And standards, there's an international standard and there's a country standard. So, and then there will be a secondary standard and then so whatever you can buy, okay, those are the secondary standard. Those are the duplicate from the country's international standard. Okay, so anyway, the standards are very important, okay, because they will allow you to calibrate your instrument measuring devices against the standard. So as I said, the calibration is a process that will allow you to adjust your instrument, okay, against the standard. So what it's measuring will be accordance with the external standard. Okay, so for example, if we are using a pH meter to measure pH, how do you know if your pH meter is working well, functioning well? So you will be measuring against the pH standard 7 and 4 or 7 and 10 and see what your pH meter measures. Okay, that's the calibration process. And there's a definition of tolerance. Tolerance means an amount of error that can be tolerated in the calibration or particular item. So tolerance will be very small. So if your instrument is working correct, right? For example, tolerance for 500 gram class 1 mass standard is only plus minus 1.2 milligram, not gram, milligram. So 1 gram equals 1000 milligrams. So it's a very small space of tolerance that is allowed. Okay. Then how do you verify if your instrument is doing its job? So yeah, the process is called a verification or performance verification. It is a way to check the performance of your instrument or system. Okay. You have to do that routinely, maybe every day, to make sure that your instruments are all functioning correct, right? Sometimes a standard is not one point. Sometimes you need a group of standards to come up with something called the standard curve. Okay, so using multiple standards, you develop some kind of graph, okay, that shows a trend of your instrument's performance. Okay, so that is called the standard curve. You may have to do that, and based on the slope of the curve, you can take your instrument measurement based on that standard curve and equation. Okay, we'll talk about that. We'll do a lab on that. And then traceability, again, that term shows up again. A chain of calibration that establishes the value of a standard or a measurement. Okay, so whatever the standard you are using in the lab, that standard should be traceable. Maybe it follows, maybe it's the secondary standard that's made out of the primary standard that's kept in the somewhere in the US, maybe. And what is that institute? The US Standard Organization. They will have their own standard. So mostly secondary standard will be made off of the primary standard. Okay, so the quality of the standard that should be traceable. That's what it means. Okay. What does that mean? Pharaoh's arm length. So the cubit length that's used in Bible. That cubit means it's the arm length of a pharaoh. So that at that time the standard of the length was Pharaoh's arm length. Kind of interesting. Okay, so this is what the traceability means, right? So measuring instruments, you'll be using some kind of standard to calibrate that, and those standards will be made from maybe state primary standards. Okay, and state primary standard will be made off of maybe secondary standard of that country. Maybe if it's Australia, they will have a secondary standard. Okay, and then those secondary standards were made off of the primary standard, and that only exists one in that country. Okay, Australian primary standard. And then each country's primary standard was again made off of the international unit standard. So it's kind of traceable back to all the way back to the international standard. Okay. Okay, when you take any kind of measurement, okay, how much error is allowed and what kind of errors are existing? Okay, so the definition of error means it's a difference between, of course, the measured value and the true value of whatever that property is. That's the error, of course. Okay, so true value minus measured value, that's the error. Okay, so error can come from these different sources. Something called the gross error. That's a very recognizable, easily recognizable and avoidable error, mostly human-made. So if your technique is not good, you will be, pipetting inaccurate volume every time. If your technique is not good, you will not be measuring the weight of your chemical compound using an analytical balance. So that's why your technique is very important. You have to practice a lot. And then systemic error means it's a subtle error that is more hard to detect. For example, the chemical itself is contaminated when say it's 99.99%, but actually due to the contamination, it is not 99.99%, it's only 80% pure. Then that's the contamination error. And the malfunctioning of your equipment, maybe it's not calibrated, it's broken inside, so that could be an error source. And the environmental causes, example would be what? In the summertime, it's the moisture is everywhere, so whenever you measure something, the moisture will add a certain weight in your measurement. Okay, winter time, of course, it's so dry, so moisture weight will be extracted from your weight measurement. So those kind of error we are talking about. And then random error, that is impossible to detect and eliminate. So that will be the only acceptable error in your measurement or in your data. So your goal is to eliminate as much of gross error or systemic error possible by having a good technique or by maintaining your chemicals, your instrument in good condition. Okay. And then critical concepts in measurement. When you measure something, your measurement should be very precise as well as very accurate. What does that mean? What's the difference between precision and accuracy? So precision means it's a consistency of your measurement. So if you are measuring one compound about 10 times, okay, do you get the same value over and over? The truth of the matter is that's not the case. You may get different number every time. Okay, then if you get different numbers, how widely different those numbers are. Okay, if those are widely different, okay, scattered all around, that means you're not very precise in your measurement. If those numbers are very close to each other, scattered in very narrow area, that means you are very precise. So repeatability of your measurement means it's precision. Okay, and how about the other term, accuracy? Accuracy means how close your measurement is to the true value. That's what accuracy means, right? So if you don't have a lot of error, of course your measurement will be very accurate. So your goal is to have your your technique well developed, so whenever you do the measurement, your measurement should be accurate as well as precise, right? So another important terms you need to have will be repeatability. The precision of measurement made under uniform condition and consistency, affected by random error only. So if you're very precise, your measurement value should be repeatable. Reproducibility, okay, that means the precision of measurement made under varying condition. So the difference in these two terms, okay. So repeatable means maybe a same person is doing the measurement under the same condition. That's what repeatability means. But reproducibility maybe it's a different person doing the measurement under a little different condition. But then under that case, how those different measurements will be close to each other, that's a reproducibility. Okay, understand the difference in those terms. So you need to develop procedures that yield results that are repeatable and reproducible. So that's the importance of the SOP, standard operating procedures. The measurement may not be done by a single operator all the time. So the measurement may be done by maybe a group of operators. Then how do you make sure that everybody is doing the precise and accurate measurement all the time? So we're talking about the reproducibility, right? And by using an SOP, standard operating procedure, you will eliminate any user error and any misinterpretable instruction error possible, right? Everyone is reading and following the same instruction over and over. You will not have the differences in different measurements. Okay, that's what the important function of the SOP is. And then how about these terms, inaccuracy versus imprecision? So inaccuracy means, of course, the opposite word for accuracy. So the combination of all random and systemic errors will affect the accuracy, of course. And imprecision means the effect of only random error. So if other things are all good, then only the random error will affect the precision. Okay. So random error leads to variability, which can be expressed as range. So range can be expressed as a standard deviation or coefficient variance. There's a mathematical way of calculating those. Okay, so accuracy can be measured as true value minus average measured value. Okay, and that'll be expressed as percent error. Percent error, the equation is true value minus average measured value divided by true value times 100. That's the percent. Okay, so if you look at the page 305 and 306, there are example problems. You can take a look at those. Okay.